Hello, Zbigniew, Marszałek. Welcome to today's session, Intelligent System and Software Engineering Advanced. The first presentation, text semantic and layout defects, detection in Android apps using dynamic execution and screenshot analysis. Packowski. Yes. I am sorry, but I don't know exactly.
No problem.
Your name.
So, can we start?
Yes, you can start.
Right.
Please.
Yeah, ще штрауки рикошет. It doesn't matter. It's my problem. Okay. Oops. Okay, so hello everyone. I'm glad that I was already introduced, so no need to say who I am. And today I want to talk about one topic. It's about software quality and it's about mobile applications. This is a presentation of work in progress, so it's still going on. And this is just initial thoughts and initial methods and so on. And we put with my colleagues kind of a little bit long title, but in short, we are looking at the application images and we are trying to find the problems in that, basically the software bugs, faults, or whatever, how we call them. So that's the idea. So let's talk about the problem, what kind of problem we want to solve it. So this is most important picture on the top, my right corner of the slide. It's usually when developers are building the application, they try their application on their only one device, the one they had at their hand. They make sure that it works fine and says, it works on my machine. And what we do, we usually make an assumption that if it works on this one, it should work on all the other ones. So what really we have? So if we have one mobile application, it actually usually it's supposed to run on many different devices, on many consumer devices. And over here, I have just a small example of application which is supposed to run on Apple's devices, and even Apple, which makes only 1 or 2 new phones every year and discontinues the old ones pretty quickly. We already have 6 devices which have different screen sizes. So basically, if a developer builds his application and it looks fine on his device, which is one of these, the tester tested on the other one device, which is a little bigger or whatever other one. Maybe it looks fine on that device too, but they usually leave 5 devices untested and so on. So with Apple, it's kind of fine. If you look at the Android applications, now we have a funny thing. When you're uploading Android application, Google is very helpful and says, thank you for your new application which was published on the market. Your application is compatible with 25,000 devices. So there is no way to check if your application actually works or at least looks good on those devices, because it's like 25,000 different devices. Luckily for us, half of them, let's say, have the same resolution and so on, but it's still a huge amount which is kind of impossible to test. So what we are thinking about, maybe we could automate that testing by just running those applications on a big set of devices automatically, taking the screenshot on each device of our application that we are testing, and then check for some defects just by looking at the screenshot. Of course, it's automatic procedure because person cannot cope with that amount of work. So what kind of defects we can find on those screenshots or applications? So there are some couple of types, like incorrect layout. So basically it looks good on one device, but it's misplaced text labels and so on. It's a little bit messy on another device because it's a bigger screen or so on. Another problem is text. Usually, if we are building application, we want to reach a bigger market, and one of the way to reach a bigger market is to provide like English version, Russian version of your application. That means internationalization. That means application messages has to be translated. And as I saw, some of the applications are translated using automated translation tools, and the translations are pretty hilarious. And some messages are basically people even translate with mistakes. They have a spelling mistakes in the text. We have other type of mistakes. Next slide I'll present what kind of mistakes we have. Okay, let's go. So a little bit short, what we are presenting here, it's not based on nothing. Basically, there were some authors, other papers published in the same area, and we were working on a similar approaches, basically detecting images. So over here is just a couple of approaches. There are some papers which actually analyzed application images and try to match if application screenshot matches the specification and so on. And over here it is also looking at the image, but we were also analyzing application source code to find out if the components are layouted in the application screens correctly. So it's some works which are basing our works on. And what I am proposing to do, basically our idea is to take one application which we want to test, then execute that application on as many devices as we can. So basically we have a pool of mobile devices. Some of them are real, some of them are emulated. That means runs on the computer in the virtual environment and whatever else. Then when we are executing that application, we're taking a screenshot of our application, which we are testing on each step of execution of each device. We did the experiment with a couple of applications, and we have gathered like 10,000 screenshots. So we have a huge amount of screenshots taken from those applications. And then we're taking each screenshot of application, which was taken on each device with various configurations, and checking for some defects. Of course, if we are looking for some kind of defects, we have to define what kind of defects we want to find. So next slide goes with a classification of a defects, what kind of defects we can find on those screenshots. This is just a small set of defects which could be fitted in this slide, where we have identified a little bit bigger set of those defects, and maybe some comments about them. Let's say what's interesting, like unreadable text, on some devices the text would be too small to actually look like, to read. Basically the font gets too small. If it looks fine on the big phone, and if application is installed on a smaller screen phone like this one, text size maybe gets too small, it's scaled too much, and person just cannot read it. So this is one kind of defect. Another is, over here, I hope you cannot see here, that's the intention. Somebody decided to paint the text with the same color or similar color of the background, and sometimes what users do, they customize their devices and override your application fonts, colors, and so on. So on some devices, your application could look totally different when it was on your devices when you were developing. Some time ago, we got a customer support with an issue with our application, and the customer reported like application is not working something. And we asked, could you make a screenshot of your application for us to look at it? And the customer sends the screenshot, and we are looking at it and like, that doesn't look like our application at all. It appears customer has customized its phone in such a way that application was using a different fonts, different colors, not what we intended to do, but what that platform allows to do that. So as a result, you can get application on some phones where the text is of the same or similar color as the background, that you cannot see it. And some other problems is like text on the messages or something on your screen is misplaced, in a line, cut it partially visible, and so on. So this is what we can see as layout problems. Another kind of problems is the actual messages that application shows. That means there is also just subset of possible problems. One of my favorite is, let's say, using incorrect vocabulary. That means technical jargon. Developers really love the messages like network error, server connection terminated, and whatever. And for actual user, it's like, what does this application wants from me? I understand only the error sentence. Another kind of problem, let's say, the messages which are offensive, not tactful, and basically offending the user. Here is example: error, 3 exclamation marks, invalid fields, please enter correct data. There is not even a please word, and another more exclamation marks. As I saw that my developers really love to use those kind of messages, and always when just allowing application to go forward to the release or not, I'm saying, oh guys, please just at least delete those exclamation marks. It's very offending to the end users. So this is another type of issues. So we have kind of a big list of possible defects which is related to application's text. So how it works, I already a little bit mentioned before. We have application which we want to test. Of course, we are not presenting everything from the scratch. There are already some work done, whereas some papers, articles, and amazing tools. We have one tool called DroidBot. It has the ability to execute your application and click everything what's on the screen and navigate your application in all possible ways. So we are using our application, the one application we want to test, and feeding to this tool, and it executes our application in all possible ways, and we are taking a screenshot at each step when this tool executes. Then we also extracting the text from application source code, because each application has a resource file that contains the messages which are supposed to be shown on this application screens, but they are not really sometimes shown. So we're extracting text from application and also taking a screenshot of the actual applications. Then we have our defect analyzer, which reads as an input those screenshots and the actual texts which were supposed to be. And it just goes one screenshot by this step by step and executes a set of rules for each defect to find it. So over here we kind of presented a rule or a small algorithm for detecting each type of defect on our application. So let's see, there's no point to explain all of them, but let's just go with my favorite ones or something like that. So for example, the text which is too hard to read, unreadable text, that means for a person using application on a device, one of the devices, it would be too hard to read because it's too small. So basically, when we're taking a screenshot, we already know on what kind of device the screenshot was taken. And we are calculating the actual physical size of the text. Basically, we measure the text from the screenshot, calculate by multiplying by device screen density, and we have a physical measure, like the text on the application screen was 2 millimeters height. Is it readable? Probably not. It's too small. So one of these. Another one is text which is too hard to understand. Developers usually use their vocabulary, write some long sentences or sometimes too short sentences, and when you look at the message, it says error, missing data. What does it mean? It makes no sense. So there is a popular, I would say, basically long time ago developed methods for measure the text readability. It's like gunning index or smoke index or I forgot the name, like 5 measurements. And you feed the passage of a text and it gives a evaluation like, is the text understandable by 1st grader, 5th grader? Do you need it to be a college professor to understand that passage of text? So we are taking application text and feeding to that algorithm and getting evaluation of a message. How hard it is to read, and let's say if the application messages are at the college professor level, so maybe it's not really understandable for a regular public, because its sentence is probably too long, it uses fancy words for regular people to understand, and it's especially hard for people where the language application is shown is not in the user native language. Let's say for us English text, like, oh, okay, I'm not really good at English language, so probably some text is too fancy. All right, so here is just a small example. We ran on a single application. We ran our algorithm, and over here, like, what happens with our tool and with our method, we analyze the screenshot, we identify the text, and over here we like extracted the text that has missing label. This is here as a missing translation and so on. So let's just skip it. Usually how it goes with a tool, or how it's supposed to work, that we have a device and the window, we basically identify in which window of application we had a problem, on what kind of device, and we have a visual proof like the text was misaligned and so on. Over here it was too small to read and readable and so on. And of course we ran on a bigger set of applications. Some papers quoted, presented this set of Android applications as a benchmark. We ran our tool methods on those applications, and I just have some interesting findings. So spell checking on some applications is not good. Then every application or many applications have those legal texts which are kind of hard to understand for people, and it has some messages that are totally obscure for what we mean. We have no idea. Then some special spell checking again. Then again, this one is my favorite one, is about offensive messages, like says error, invalid name, like shouting at the user and so on. And of course translation. Some of these applications were translated using automatic tools, and I just looked at the text, how it looks in our native language, and it's hilariously funny because it uses the wrong words for the things actually we wanted to say. Okay, so this is not really a conclusion because the work is still in progress. So we have a tool method which is similar to static code analysis. So developer has to do just ran it on its application, and it gets a report with a suspicious places. And then it's up to developer to look at those. The report says on this device, the application looks like that, and this is the place where it's something wrong, and that wrong is like text is clipped off or something like that. So it allows to identify. And as what we found from our couple of experiments, it's exactly as I mentioned before. Some applications on which we tried to our tool, they were translated automatically with funny results. Some applications were translated not fully. That means half of the user interface is in one language and another half of user interface is in another language. So with our stuff we can identify those applications and say, in this window you have text in French and English on the same window. Is it all right? So spelling, some applications had messages which are really hard to understand, very long, using vocabulary, technical jargon, and so on. So this is more like that. And I forgot the slides with the questions.
Thank you very much for your presentation. Would anyone like a question? No?
Oh, yeah.
Yes?
So I can ask a question.
Yeah.
I did make what are the influences of different languages? Have you encountered any, because different fonts, for example, I'm from Poland, so it's with different fonts.
Yeah.
It's like it's got also different fonts from English. Like, we need different encoding. So also, have you encountered any problems with encoding different?
Yeah, we have something about encoding, but what we found, the bigger problem with different languages, if you have a sentence in English, it's quite short.
Also,
If you say it in, I'm not familiar very much with Polish language, but in Lithuanian language it's like that. In German it's even longer, and it does usually do not fit on the application screen. So this is one of the defects, which means partially clipped text or partially visible. So this is one of the things that the text will be clipped, and with those special letters like my name also starts with S letter with something on top. Android applications are pretty good handling those special symbols, and we haven't seen a problem with that yet. But it's a possibility, and we kind of defined another defect type because we're reading a text from application resources, and we already know what kind of text it should be, and we are also searching for that text on the screenshot. And in some cases, we are supposed to get a question mark or an empty space if the font was used some special. Default fonts are usually okay.
Yes, okay.
thank you.
Okay, thanks.
Thank you. Sometimes you have a text with different languages, in Polish, English,
Yeah.
and how to recognize and how to...
All right. So basically, what happens when the application starts? We are starting it in a controlled environment. We're saying you're running on this kind of device with this screen size, with this peripherals available or whatever, and one of the parameters is the language. So basically, we can force the application to run in English, Russian, German, whatever language we like.
Yes, okay, but what happens if it will be Russian and English?
In the same application?
In the same application, it is possible.
Yes. So that's a good question. That's why our tool and our method, it doesn't say that this is a problem. It just says, this is some place which is suspicious. Maybe you did it on purpose, or maybe it's by mistake. Because what happens usually, I checked some of applications, and they usually translate the main messages. When another developer goes to work, he adds the new messages but leaves the first one untranslated. And then user interface combines both of them, and you have half English, half Russian, whatever. So this is the tool that the method just flags as something suspicious. It doesn't say this is wrong, and it's up to developer to say, oh no, it has to be like that, discard it. Yeah.
Thank you very much.
Okay, thanks.
The second presentation, the impact of the cost, the function of the operation of the intelligent agent into the games. Dawid, Połap. Oh, moment. I forgot. Thanks. Thank you very much.
Okay, so welcome everybody. My name is Połap, and I would like to present a paper wrote with my colleague Marcin Woźniak. We are with the Institute of Mathematics in Silesia University of Technology. The topic is the impact of the cost function on the operation of the intelligent agent into the games. Okay, so the contents of my presentation have 4 parts. In the first one, I will say a few words of introduction. The next one, I present the proposition that we describe it in the paper. Next, we will describe some experiments and results. And in the 4th part, I will sum up the whole topic. Okay, so quick look at the problem. A large part of the technology development depends on the needs of the user. I believe that all of us know that when we get some new software, we all say, oh, it's nice, but we still would like to it better. We want something as better or something else. A special group of those people is players who want, when they have one game, they finish it and they say, okay, but the storyline could be much longer. It could have some more plots, and the graphics could be better. And here there is some drawbacks there, and this drive the market. That's why we need to create more efficient algorithms and more efficient algorithm to increase the playability of games. Okay, so our proposition is to propose an agent that will moved by artificial intelligence technique in some games. For our example, we used a classic game to the worlds like The Throne, which is inspired by a classic movie in that field. So we propose hybrid approach where we used several strategies that could be changed during the process of the algorithm. One of these is inspired by simulated annealing algorithm. Okay, so about the agent, a basic idea. The agent will be called, of course, algorithm that is responsible for the operation of our player drawn by computer. So we have definition of the agent. The second definition is the board. The board, it will be called environment in our proposition. Our agent can move over the board, but he cannot exceed some size of the board. And we assume that our algorithm can't know everything. So he won't be predicting the move of the player. That's why he will be called not omniscient. Okay, another assumption that our algorithm gonna make them will be make the move only on the assumption of observation from the position where he is on the board. So we describe two agents that can make decision, and it could be done by one of the way. The first one is episodic, and the second one is sequential manner. So the first one, episodic way, is the movement that is made using some observation from a given position. So he won't use it a previous step. The second one is a sequencing way, which is understood that our player will make move, but he will use data obtained from actual position and his previous step. Okay, so our proposition of intelligence agents operation. So our agent gonna have some strategies, and he will choose one of them using some function. We call it this as measurement function, and it's described in equation 1. As we can see in this equation, we have two functions, d and g. D is understood as a metric, which is the length from actual position to the position of player. And the second function, g, is the number of fields that can have some obstacle that need to be, let's say, that when the obstacle is met, he must go another way. And we have here two constant value. This is epsilon and omega. There are the sum of these coefficient must be equal 1. Okay, so we understood that our algorithm has three strategies. The first one is pursuit, which is quite simple because we take the 2 points. The first one is our player, and the second one is the position of the computer. We calculate the distance, and we take one move forward where the distance using some specific metric will be the smallest. The second strategy is random movement, which is the simplest one because our opponent just take one step in random movement, random field. The second one is inspired by simulated annealing. It's a heuristic algorithm used in metallurgy. And here we have some assumption. We have two positions. We have position of the player, position of the computer. We have some initial temperature T. Is at the beginning of the algorithm. It is a constant value. After that, we have constants mu. Mu is understood as a position where our opponent can move. So we try to calculate this value. And the value is chosen when this equality is satisfied in equation 2, which is understood as accepting the new solution. During this algorithm, we have some iteration. In our researches, we use 100 iteration, where the temperature was just smaller with each iteration, and the equation for decreasing this temperature is an equation 3. Moving forward, our algorithm is quite simple. It can be understood with this pseudocode. At the beginning, we define some cost function. This was this formula with two functions f and g. Then we define actual direction of the movement. At the beginning, of course, it is a random move. Then we calculate the cost of each of the strategy and choose this one which has the smallest value. Then we choose this direction with the lowest cost. Okay, so our experiments. We implemented solution in C#, and our experiment contains classic game Tron. We used 100 tests. Half of them was played by computer versus player. The second one was computer versus computer. And the basic test, in here we can see that we used two metrics. The first one was Euclidean and the second one was Manhattan metric. In both cases, we calculate average time when computer won. And it's simply to see that in the play, when algorithm played against the computer, against the player, Manhattan metric was better. The result of that is quite simple because Manhattan assume that we will go, but we will choose this way that cannot have any obstacle. Okay, so going further, we have some conclusion, and our result, Manhattan metric, was better. This solution can be implemented in different games, especially in 3D games, because the one only thing that must be changed is the equation. Is equation 1, which is the formula for move player. Okay, so that will be all from me. So thanks for the attention.
Thank you very much. If anyone would like to ask a question, I would like to ask you about the players.
Okay.
You have only 2 players. It is possible to more players?
Yes. It is.
You don't test it?
It doesn't depend on the game, so it shouldn't be any changes in the algorithm.
Okay, thank you very much.
Thank you.
It's your certificate. Thank you very much. The third presentation, automated design function orientated on innovative personified projects. Petr Sosnin.
Yes. I didn't find desktop and I can't know how can I do it. Help me please. You. I didn't.
Here?
Desktop. Just a minute. Vilnius. A little let me.
That's cool.
It isn't desktop. Just a minute.
This one.
Yes. And automatic slideshow. Thank you. In international conference, I start with the place where the reported study was conducted. It is Ulyanovsk. Just a minute. Middle Volga, about 1,000 kilometers from Moscow to the east, and about 1,000 kilometers for the Caspian Sea. We have two bridges, if you see, and one of them is about 6 kilometers above water. So our study is presented in this agenda, and in introduction, I start with an investigated condition. A person who hasn't sufficient experience in software engineering has a reason to estimate of an innovation without intermediaries, wants to build and investigate prototypes of its materialization, wishes to express the obtained results in understandable form for professional development. And in such condition, we suggest to use our version of automated designing. Such version is the next step in our long-term investigation of the problem of successfulness in development of software-intensive system. Such problems investigated, but many scientists and each year one corporation publish reports with positive and negative factors that influence on the problem of successfulness. In these problems, we investigated direction connected with human-computer interaction, architectural modeling, design thinking, and conceptual space. Base of our research is a reflection of the operational space and design in the software system on the semantic memory. You can see on the corner of this slide the operational space and its reflection on the semantic memory. We investigated reflection in conceptual designing, communicating during design, documenting, automated learning, agile management, experience-based, conceptual experimenting, automated imaging, and design thinking. During such reflection, all essences that concern the process of designing is reflected on the space of the question-answer memory with cells, the structure of which and content you can see on the right corner of this slide. In conceptual designing, we use question-answer reasoning and register it in the version of question-answer.net as for team of designers, so for the tree of the tasks, for practice, and all of these structures are used in design process. We interpret all such question-answer nets as conceptual space, and it opens the direction for investigation, interaction with such space, activity in this space, moving from the point to point, from object to object, and about the regularities of the conceptual space. As I talk, we use question-answer model of conceptual space, and even methodical interpretation helped us to investigate and to build instrumental means for experience-based human-computer interaction, conceptual experimenting, and other activities that you can see on this slide. Interpretation, the surrounding of and operational space of designing in the form of conceptual space led to some positive effects, some of which you can see on this slide. It is this space is a source of restriction, requirements, support creative activity, compliance of regularity, control use of lexicon, controlled evolution of space, project, and theory. So we investigated it, and it helped us to construct conceptual space as artifact that can be used during design process. And in any project, we can start with empty state of conceptual space, and step by step we can create base of precedent, project ontology, and other useful artifacts. Moreover, we can present the conceptual space through the traces of registering with this space in question-answer reasoning, in question-answer interaction with such space, and such base helped us to define and to create for any project substantially evolutionary theory of this project. Now about the investigated condition and about automated design thinking in our version. This version has traditional steps: empathize, define, ideate, prototype, test, and all such actions connected with activity on these steps is supported by project ontology and semanticized graphics. In such steps, at the end of prototype step and testing, we create the solution in the form of precedent by using the different activity. So during our version of approach, we step by step interpret our action in form of conceptual experimenting that helps us to develop in the model of precedent and to create the solving the new task using mental imaginations. Some simple actions. Design thinking suggests that the first step is starting from the discourses that express some intention of on potential use. Here you can see the initial statement of the tasks and question marks that give us the point for question-answer interaction with our natural experience and model of the experience that is accessible in the work with project. Some details of question-answer reasoning or question-answer analysis of the textual units. And during such process, we use not only ontology but the experience base, and the conceptual space reflected on the semantic memory gives us the possibility for pseudocoder programming that helped to build the executable prototypes. Here you can see some features of the question-answer analysis, and all process of design thinking on the example of the tasks that was aimed on the creation of semanticized graphics. Such instrumental means was built and embedded to the instrumental environment for modeling of question-answer, reasoning, conceptual space, theory, and automated designing. And now some steps which concern the dynamics of design thinking. Here you can see 6 version of analysis of the tasks, during of which the block and line scheme that present the statement of the text is reached step by step. Here you can see the first result and the last results of analysis of the tasks, and you can see the block and line scheme that we can register in our instrumental environment. During such process, we register concepts that will be used in the statement of the task during its specifications. And very useful result is initial states of ontology of the projects. So if we return to the investigated condition, we can conclude the application of the design thinking helped to build a set of executable architectural views that are registered architectural understanding, cause and effect understanding, initial state of the conceptual space, initial state of the project ontology, initial state of the project theory. We register results of our investigation on the ResearchGate nets, and dynamics of interest to our work you can see on this slide. Each week about 100 reads is typical for access to our results. In this year we published our results in the monograph and in 4 publications. And if you are interested in my report, you can look in this publication some details about it. Here conclusion. Thank you.
Thank you very much. If anyone would like to ask a question? No? Yes?
Can you please explain a bit more about project ontology? What is the purpose of it?
When we start,
How you are going to use it?
yes, I understand your question. I'll try to explain. if we start any project, we start with the empty state of ontology. And during processing of discourses, empathy phase and define phase, we extract the concepts from such textual material and formulate some states of concept. And if you can see, during investigation of one of the tasks, we finished our work when we define initial states more than 60 concepts. For this, we use our version of project ontology, and it also upload into the semantic memory of the question and type.
And are you using any particular tool for reading and browsing of ontology?
No.
In what form ontology finally is defined?
What?
In what form? Is it any kind of meta tags?
No, I'll explain. We created our version instrumental means for defining article of ontology from the empty states, and it has not only definition but some features connected with systematization, with relations with other concepts, and we don't use any formal means. It is natural language definition and the relations between such definitions.
So you don't use XML, for example, for exporting of your ontology or something like that?
No. It is our version dictionaries connected with each other.
And your dictionaries, are they related to any kind of standard thesaurus where you extract your terms?
When we process the next unit of textual expression, we compare the words of such textual units with current states of ontology. And if any word in investigated units is absent, we extract it, and after that we define some features that is presented in this sentence, or connected with, for example, other sources of information connected with this word.
Yes, okay. Thank you very much. The next presentation, a concept of a cooperation of a concept in global probabilistic approximation based on meaning in complement data. Here, Mr. Jerzy Grzymala-Busse. Yes.
Okay, so I would like to discuss. I cannot switch from.
Okay, so
This is not complete.
Okay, is it a PDF here somewhere on the disk? Is this?
Uh-huh. Oh, it works. Thanks. So we will discuss mining of incomplete data sets using two different approaches, both based on rough set theory. Using rough set theory, we can use interpretation of missing attribute values. In my presentation, I would use two types of missing attribute values. One is lost value, which means it is completely erased. We cannot use it anymore. And the second is don't care condition, which is completely different interpretation. For example, we are collecting some questionnaires, and some of guys refused to answer the question. The question was maybe not convenient. So this is an example of a little data set with both lost values that are denoted by question mark and don't care conditions denoted by asterisks. And our main objective is to compare the quality of two approaches to rule induction. One is based on concept probabilistic approximations, and the second on global probabilistic approximations in terms of an error rate. The basic tool that is used here is the block of attribute value pair. And this is a way to distinguish between lost values and don't care conditions. For lost values, a block is defined in a completely different way than for don't care conditions. So it is a very simple idea to incorporate semantics to managing missing attribute values. For our small data set, you have here blocks of attribute value pairs that are computed here. For temperature normal, it is 1, 2, and 8, because if you look at the data set for case number 1, number 8, the values are normal, and for 2, it is don't care condition. In don't care condition, we use everything. So this is why the block is, for every attribute and its value, we can compute a block. Now, the characteristic sets is the next important concept. It is basically it is the set of all cases that are indistinguishable from each other using given semantics. For our little data set, all characteristic sets are listed here, so you can deduce from it that for the first case, this is the unique case. There's no other cases that are indistinguishable. For case number 2, you have 4 cases that are in the same shoes, and so on. We will use 2 basic approaches to probabilistic approximations. The first is a singleton probabilistic approximation. This is the set of all cases such that the conditional probability of the concept given characteristic set is at least equal to alpha. Alpha is interpreted as a conditional probability, and it is parameter that is given by the user. The Another possibility is to change a little bit definition. It is now union of some characteristic sets. And the third definition is also a little bit different. It is union of characteristic sets restricted to the concept. And since we are talking about probabilistic approximations, people usually will get an idea that there is very many approximations of this type. This is not true, because for any characteristic sets you can compute the sets of all conditional probabilities. With the number of different probabilities is very restricted, and so the number of corresponding approximations is also not too large. For example, for the concept 1 and 2, you have here absolutely all probabilistic approximations. There's only 4 of them. For subset approximations, it's even less, only 3. And for concept probabilistic approximations, we have only 2. Now, the second approach is called global probabilistic approximations. And here you have the general definition. You can come up with any subset Y, denoted by Y, from our universe. And all what needs to be done is that conditional probability for given concept, for concept given characteristic sets where X is taken from this set is greater than or equal to alpha. Obviously, this is a very general definition, and it leads to exponential complexity, because Y is an arbitrary subset. So we have to correct it, and it is corrected in a heuristic way by selecting only some characteristic sets that are the most relevant to the concept. This is the first criterion. If you have a tie, then you select the characteristic set with the largest conditional probability, and there is still a tie, you select it randomly as the first on the list. So for our little example, you have here all global probabilistic approximations, and it is pretty obvious that in this example, for this concept, global probabilistic approximations are better, because approximation for the first concept, 1, 2, has only 3 items, once before, for concept approximation, it had 5. So it better approximates the idea. We can also use the idea of definability, and this is just to make sure that our concepts can be expressed by rules. If concept can be expressed by rules, it is locally definable. You can show that singleton probabilistic approximations are not so good, because occasionally approximations are not locally definable, so you cannot find a rule set. In our experiments, we didn't use singleton approximations, we used only concept approximations. And we use 8 data sets that are typical data sets taken from the repository from University of California at Irvine. In all of those data sets, we replaced randomly 35% of existing attribute values by symbols of question mark, and then replaced them by asterisk. So this way we got 16 data sets. And here are results of our experiments. You can see that depending on type of approximation and interpretation of missing attribute value, there are huge differences between all four approaches. Let me repeat, we use concept, probabilistic approximation, and global probabilistic approximation, both combined with lost values and don't care conditions. Here the differences are even larger. So for all 8 of data sets, there are huge differences, and some of those data sets are numerical, some were symbolic. As conclusions, we compared our 4 approaches basically for 2 data mining. And first of all, we can compare we can compare global approximations with concept approximations. And the conclusion is that concept approximations were more successful in general. It means error rate was smaller. And then we can compare 2 interpretations of missing attribute values, lost values with don't care conditions, and here the difference was not statistically significant. And those are all conclusions that I would like to tell.
Thank you very much. If anyone would like to ask a question? No? Thank you very much. Okay. Thank you very much. The last presentation, a study in granular computing, homogeneous granulation. Yes.
I'm here. Thank you very much for the introduction. At the beginning, I would like to apologize for my voice because I'm fighting with a small cold, and maybe I will do some voice during the presentation. I was working together with Professor Petr Artemiev, and I am a co-author of this presentation and article. So it's a study in granular computing, homogeneous granulation. Outline of this presentation, we start with our motivation and then following with introduction to general to rough sets and rough inclusions, and then I will try to explain how our new method works and what is the difference between methods we are comparing with. Then we'll show a small toy example, how our method works, and some experimental session and results, followed by conclusion and future work. So our first motivation was a need to develop methods that could reduce the data size, dataset size, but at the same time preventing losing of the internal knowledge regarding to rough inclusion theory. Some of the methods are already developed. Methods that we were comparing to was the standard and concept-dependent granulation, which are by now the best methods in this field. Our other motivation was need to reduce the computational complexity of methods. Maybe they are not the most CPU consuming methods, but if there is a possibility to reduce the time needed to compute, why not to do it? So it's introduction and rough inclusion. So when we are comparing two objects, we are looking for some indiscernibility, or in other words, similarities regarding to some degree. Here it's letter R. So when these two objects are somehow comparable or have some number of similar attributes, the inclusion is present. When we produce our granule of knowledge, so we are combining together objects that are somehow similar, we are building and covering the initial data sets with those granules, trying to prevent the internal knowledge, and then we, when there are ties, so we are not sure which new objects should be produced from the granules we've made before. We can use majority voting to pick up the most occurring values for each attribute, and ties are resolved by random. After building granules of knowledge, we are building a new data set basing on those granules and reducing the number of attributes. Of course, the reduction rate depends on the diversity of data sets. The more the data set is diverse, the harder is to the reduction is. So we'll see that on the results. So a few words about concept-dependent granulation. Concept-dependent granulation is a granulation which is made only in the same decision class, so we are comparing only objects with the same decision class value. And in this standard and concept-dependent granulation, the granulation process was performed for every attribute. So, for example, as the toy example will show, when we have, for example, 4 attributes, we need to build granules for each of the attributes separately, then compute the accuracy for each new data set and pick up the best of all those. But in our approach in homogeneous granulation, we are letting the data to decide what is the best radius of granulation, because we are picking up objects hierarchical or by random, and then we are looking for similarities in the whole data set, not only in the same decision class. But when we are finding some conflicts in a decision class, so for example, when there are 2 objects similar by a given means or by a given radius, but the decision is different, then the conflict is discovered and the process is stopped, and we are now we know what the radius for the granulation is for this particular object. A few equations about how the granulation process is performing or is being run. These are some similarities to concept-dependent granulation. There's only small difference on how homogeneous granulation is made, because we are starting with the whole objects with all the conditional attributes, and then lowering the similarity ratio or increasing the indiscernibility ratio, and trying to find the optimal value. As a covering method, we chosen a random choice because it showed that there is a good performance, better than in hierarchical one. This is a toy example with some data we were testing on. Results are also presented for bigger and more diverse data sets. So as the first step, we are picking the first object and looking for some similarities. Of course, this object is similar to itself in a full degree. So in this particular example, we are looking for all 4 parameters with decision class. But there are no duplicates in this dataset, so only this object is currently in the granule. Then we are looking for any 3 attributes that are similar. So we're starting with the first 3, but there is none. Then we are picking up the next 3, there is none. And the last combination, there are no candidates. It's as we see at the bottom, the current radius is 0.75. It means that we are looking for 3 out of 4 attributes in this data set. Then we are lowering the radius and looking for 2 similar attributes. There is one candidate, valley, sunny, and high with the same decision. So we are looking further, but there is a first conflict when the sunny and strong attributes occur in the same position, but the decision is different. And the process is being stopped at this moment, and we are picking up the former radius, so 0.75. And then all the granules are built for all the objects. When there are more similar objects, the granule can contain many other elements. Then we are building the covered data set, but by random choice. So the number of granules currently here can be in much different order. So this is not deterministic. And number 3 is already in. So the granule contains already object 3, so we are not picking it up. The same with object number 5, and then you are reducing the number of attributes of objects in our data set. So our final granular reflection data set looks like this, and in the means of rough inclusions, the internal knowledge is preserved. That's our experimental session. We have been testing this method on this data set, so starting from 7 attributes up to 20 and almost 13,000 of elements, and only from 2 to 5 decision classes in one of them. A little bit about the classifier we've used in this experiment. The KNN classifier was used to classify and measure the effectiveness, the accuracy of our system. So we are dividing our data into training and testing data sets. Then we are also computing the optimal K attributes, with condition that when there is not enough elements in the smallest decision class, the K is set as the number of those elements in that smallest class. And the optimal K for each data set was calculated. We have been using cross-validation 5 method to pick it up. And then we are calculating weights basing on the Hamming matrix. And then the concept weight is the sum of all weights for the compared objects for training and testing data sets in one single concept, so one single class. Then when we are making the classification process, we are picking up the minimal value of concept weight. And as a result, as you can see, in the first column we have our accuracy of 5, cross-validation 5 method, then the mean granular size, then the training dataset size, and the percentage of objects that have been reduced from this final dataset, from the initial dataset, and the RADI range that could be used to obtain the optimal accuracy and preventing the internal notch. Our results have has been compared to the concept granulation methods, and those results are comparable. So we are not performing well in all the data sets and all the examples. Some of our results are slightly better, some of them are slightly worse. But it gave us motivation to do some more research, and we have already some better results with ensemble models. So, as a conclusion, it's our idea was to simplify the process of granulation, and we did it by performing the granulation only one, not for each set of attributes. And if it comes to data size reduction, it's almost comparable to concept-dependent granulation. So the results are the same if it comes to accuracy and data size reduction, but the time needed to perform the computation is slightly smaller, but we have not made any particular measurements, and we are planning to do it in the future. So in our future work, we are planning to use other different classifiers, and we have already did some research using ensemble models, and the first results were about 2 or 3 percentage points better than the well-known methods as boosting or bagging. So these results are quite promising. And finally, we are thinking that maybe tolerating a small fixed percentage of objects from other decision classes, but with similar attribute values, could provide some better classification results. Thank you very much.
If anyone would like to ask a question, yes, please.
So if you can reduce your training set to 50% and still have accuracy, can you even reduce it further and still have like 90% or 80% or 70%? Is there a correlation?
Yes, there is, because when the reduction rates get higher, the accuracy gets lower. So we've made some tests, and concept-dependent granulation, where we are picking up and trying to find the best granulation radius, shows that there is about, the optimal value is about 0.6. It means that we are looking for slightly more than a half of same attributes in the datasets. When the value is lower, then the accuracy is decreasing quite large.
And the second part of that is, if you have just X number of records, 10,000 records, and that's your training set, does it matter which 5,000 you take out, or is it sort of random?
Well, I'm not sure, because we haven't analyzed each particular object on the bigger data sets, just final conclusions, final accuracy, but it's a kind of some randomness in the whole process. So I think that might be slight differences, but we are trying to use methods like cross-validation 5 to mix the data a few times to prevent from overfitting or maybe some bad pickup by the random methods.
Please.
How about in information theory, you have this kind of concept entropy. Have you tried to this kind of idea that if you cut this data set or sync it, how much the entropy of the data set is changing, and that way to think about that?
Well, that's a good idea. This is a preliminary research, so there's actually the first research that we have been made about homogeneous generation. So it might be a good idea to check it in the future. And I think that me and Piotr will try to develop some new areas. If the results are further results will be promising, I think that we'll think about applying it or testing with other methods.
Okay. If anyone? No? Thank you very much. Thank you. Okay.
Also, a special thank to our chair for excellent sharing.
That's certificate for you.
Thank you very much.
The session is closed.
Session is closed, but please do not leave the hall because we will have a tutorial on Smart University starting shortly in a few minutes.
You here?
Yes. Yeah.